So we're going to look at this matching question, which will help us to understand matrices. Basically, you would look at, let's look at matrix A. It has three rows because the row would be the horizontal set of numbers, and it's three columns. So the size of this matrix is 3 by 3. You always go row by column. So as you look for a column matrix, we are looking for a matrix that only has one column, and as you scroll down, you'll see that there's only J is the only matrix that follows that description. The row column will be the matrix that only has one row, and that would be C. So these two are going to be easy to spot. Now, the identity matrix has only ones and zeros, and the one will be on the lead diagonal. When we say the lead diagonal, it's going to move down, as opposed to we have another one here where it starts from the bottom and moves to the top. This one starts at the top and moves to the bottom. So this diagonal only has ones. Everything else is going to be zero. This is your identity matrix. The diagonal matrix, I had to look this one up. It says, let's see, where is it? Oh. So this was just an example I found of the identity matrix. Apparently I had to look this up as well. So notice the lead diagonal only has ones. This can increase. A 4 by 4 would have only ones along that diagonal as well. But the diagonal matrix also is only in the lead diagonal, but it can have numbers other than 1. So that would have to be E. See, there's a -1 here, which stops it from being an identity matrix. So a square matrix would just simply be a matrix that has the same number of rows and columns. So we have already used A, we've already used E, we have H here, so that's the only one that's left that has the same number of rows and columns. So through process of elimination, we come across this because this is a square matrix and so is this. Now, because it's a matching exercise, you want to be as precise as possible. Because if you had put one of these, if you use A here as a square matrix, that is true. But then that would mean that when you get to H, you wouldn't have anywhere to place it. This is not an identity matrix because it doesn't have the lead diagonal. So we get to the difference. So in order to add or subtract matrices, the matrix size must be identical. So this has 2 rows and 3 columns. This has 2 rows and 3 columns. That's the only way you can add or subtract matrices. The size must be the same. So when we look at this, it's going to be the 3 will take away the 2. The positions must match. So this is row 1, column 1. We'll subtract row 1, column 1. Row 1, column 2 subtracts row 1, column 2. Row 1, column 3 subtracts row 1, column 3. So the positions must match. And since there were 6 positions, you should have 6 respective answers. Be careful with the negative signs. Notice this is a this will subtract the -1, which will change this to a positive. If you're using a calculator, you shouldn't have a challenge though. So this is the one that has 1, 3, -4, -2, 6, and 4 is what you're looking for. You would have to actually work that out to see that, and that is going to be the G. So we get to the transpose. So when we transpose, the rows become the columns, and the columns become the rows. So you have 3 rows, you will end up with 3 columns. So you're looking for -1, 3, and 2 in the column position. In the row position. And 2, 6, and -4 in the row position as well. So this column matches this row, and this column matches this row. So that's why this is F. So we get the product. Now, product is going to be one in which you need to know how to multiply matrices. So I think I'd mentioned how important it is to remember row by column. So when multiplying, we always multiply row by column. So when we get to the multiplication, we have to test it. So we have a 2 by 2 matrix that has to multiply a 2 by 3 matrix. Notice I have these in red. If these two inner numbers do not match, then you cannot multiply those matrices. It's going to be impossible. Don't even attempt it. So therefore, if these two match, what happens is when you remove the twos in the middle, your matrix is going to end up being a 2 by 3. Okay? So the way it works is, so we have the row must multiply the column. So row 1 first must multiply column 1. And it's going to be in the position. So this 0, which is the first number in the row, must multiply the first number in the column. So that's 0 by 2. This minus 1, which is the second number in the row, must multiply the second number in the column. So minus 1 by minus 1. And then we add those two products. Now, depending on how many numbers there are, you may be end up adding a number of numbers, or you might be multiplying a number of numbers. But it's always row by column. And so therefore, when row 2 multiplies row 1, the first number 1 must multiply the first number in the column. And the second number in the row must multiply the second number in the column. So in respect to row and column, the position is the same. And I want you to notice how we have the first matrix in red. Notice it's 0, 1, minus 1, 0, 0, 1, minus 1, 0, 0, 1, minus 1, 0. Okay? And then as we go across, it's going to be 2, 6, and minus 4 in the first position for the first row, and minus 1, 3, and 2 in the second position. I use the color to help us to see this a little bit better. And it shouldn't say minus. That should be a multiplication sign. Okay, because we're multiplying, we're not subtracting. So what happens is when we take the 0 and multiply it by 2, you get 0. Minus 1 times minus 1 is 1. And so you're going to get 1. So we are adding these two products. And so this is what we're going to get. You can pause the video if you need to study this in greater detail. So that's 1 minus 3 minus 2, 2, 6, and minus 4. So that's what we're looking for the matching, and that's going to be D. And then finally we get to the product of these two. And let's have a look at the working for that. Once again, when you do the test, it's a 2 by 1 matrix multiplying a 1 by 3 matrix. And since the ones match in the middle, that means it can work. And then you just eliminate this, and the outer numbers would be the size of the matrix we're looking for. And once again, I have the wrong sign here. Let's fix that. And so it's going to be row by column. So the 1, minus 1 will multiply the 1, and then the minus 1 will multiply the 3, and then the minus 1 will multiply the minus 2. And then you get to row 2, and really this is row 2. 2 by 1, 2 by 3, and 2 by minus 2. This one is way more straightforward. It's because it's a smaller matrix. And you're going to get minus 1, minus 3, 2, 2, 6, and minus 4. And that, of course, will match up with matrix B.